Okay, hello everyone. Welcome to the next video of Lab 1. In the previous video, we added the minutes counter in our digital clock, and we also integrated the PMOD 7 segment display. Now we need to update the XDC file so that we can connect the output, which is this anode and the cathode of the PMOD, to the corresponding PMOD 7 segment display. Now this is our XDC file. So before we go into the details, we need to understand how the 7-segment display is connected to the PMOD ports of the Basys 3 FPGA. So this is our PMOD 7-segment display. And here you can see that this one has the total 12 pins. Out of those 12 pins, you can see that there is one pin for the segment A, another for B, third for C, D, then E, F, G, and this is to switch between the display. So this is our anode pin, and these are our 7-segment pins. So we need to connect this to the our cathode and the anode PMOD signal. Now this 7-segment display, you can go look into the details necessary. So you can say that a pin is connected to the segment A, B, C, D, and this one is the digit selection pin. So for us, these are the location is important. Now we are going to connect this Basys to the Basys 3.1, and we are going to connect it to these two PMODs, which is close to the 7 segment. So there are total 4 PMODs are there. So here you can see that this PMOD is a PMOD B. Then this PMOD is a PMOD A. Okay, you can see the name here. This PMOD usually called as a PMOD XDC, and this PMOD is a C. So you can see this is the A, B, C, and XDC. So we are going to use this PMOD. Now on each PMOD, you can see that there are total 12 pins are there. So we'll go to the PMOD section. So these are my 4 PMODs, and on each PMOD, so for each PMOD, there are total 12 pins are there, out of which the last 2 pins are upper and lower pins are for VCC, and then next 2 are for ground, and these are the pins we can use. Now we are going to connect our PMOD to the lower one. You can connect it to the upper one also. We are going to connect to the lower. So we are going to use 4 pins of the one PMOD, lower 4 pins, and another lower 4 pins of the another PMOD. Okay, this is how we are going to connect. So this is these are the 4 pins because these are the ground and VCC. And similarly, these are the next 4 pins. We are going to connect these 4 pins of the PMOD A and the PMOD XTC. Okay, so you can see that this is pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we are going to connect this PMOD. So we are going to connect the segment A to the XDC. Okay, so you can see that we need to connect A here, B here, C here, D here. So these 4 pins A, B, C, D will be connected to the XDC PMOD, this one, and those corresponds to the N2, K3, M3, M1, N1. Just keep this name into the mind. So we will connect it to the K3, M3, M1, N1. So we'll connect the A segment to K3, B segment to M3, and M1, C, and D. Then we are going to connect the EFG signal to the your AP mod signal. So AP mod is this one. So H1, K2, G2. We are going to connect the remaining 3 segments, and anode we are going to connect it to the G3. Okay. So let's go to the our XDC file. So XDC file, you can see that all the pins of the Basys 3 will be there. So you can see that from the A, from the PMOD A, we need the pins which are, I think, the bottom 4 pins. Okay, so we need the bottom 4 pins of the PMOD A. Okay, so you can see that uh, okay, I have already connected this one. So you can see that I'm going to connect the anode, and then I'm going to connect the seventh one, because our MSB bit is the segment A, and the last bit is the segment seventh segment, A, B, C, D, E, F, G segment. So these are the three I'm going to connect it to the PMOD cathode of the PMOD A. And then I'm going to go to the XDC, and again I'm going to connect the 4 segment A, B, C, D here. Okay, so you can see that the 4 segments. So this is the segment A, the sixth bit, that is MSB bit, segment B, segment C, segment D. Then I'll go to the next PMOD, E, F, G, and then the last is the my anode signal. So this is how I'm going to connect it in the XDC file. So with this, our XDC file is updated. Now we are going to generate a bit stream, and we are going to test our design on the FPGA board. So I'll generate the bit stream. So I got one error that the B1 instance is already defined. So I'll modify it to B2, and I'll generate the bit stream again. Okay, so the bit stream generation has been completed. So now we'll go to the project folder, and we'll copy the generated bit stream in our local PC so that we can deploy it on our physical board. So this is my local PC. I'm using on the local PC. I'm using 2019.1, and on the server PC for generating the bit stream, I'm using 22.1. So I'll directly go to the Open Hardware Manager. Open target, and here I'll do the program device. Here I'll select the bitstream which I have recently copied. Okay, so now I'll show you the display. Okay, so this is the default program. Now I'm going to program the FPGA board. So the first thing you should look at is the PMOD 7-segment display. Here you can see that I have connected to the 2 PMODs, and here you can see that I'm connected to the lower pins of the PMOD. This is the PMOD A and PMOD XDC, and the seconds values are displayed on the PMOD as well as on the 7-segment display. Now the next thing you will see that when my seconds counter reaches the value of 59, then my minutes counter will be incremented by 1. Okay, and you can also set both the counters to 0 by using the reset button. Okay, so with this we have completed our task 2 in the lab 1, where we have displayed the minutes as well as the seconds counter on the 7 segment as well as the PMOD SSD. In the next lab, we will discuss about how to write the test benches, and we will also discuss how to set the seconds and minutes counter to any desired value using the push button and switches.